started and didn't give us any
You missed
more.
the easy shot.
Oh.
Don't worry, you should have counted.
Okay. So this shouldn't take too long. Oh. This shouldn't take too long to cover. We're going to talk about compound events. Remember last class we talked about like single events. What's the probability of rolling a 4 on a die? It's 1 out of 6, so on. So basically a compound event is when you have 2 or more simple events.
Oh, we're finishing this lesson. Oh, no, we finished that.
We listened to, we finished that lesson. We're going to go to 4.3.
But not finished it.
We probably will finish it. So
That's quick, yeah.
yeah, so we might have 2 days to review because we have a quiz after 4.3. So anyway, basically there's this addition rule. And do you recognize this union notation? Does anybody recognize that?
Where?
This notation? So
Oh, and
union is like how we would read or. Like this is how it is in words. It's the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So basically what this does is it makes us, this is so we don't count things twice. Because you have to be careful, like we're going to look at the example with a deck of cards, and we want to figure out the probability of 2 events occurring, but you could have a combination of the 2. So we want to make sure that we don't accidentally count those events twice. So what's the probability of drawing a heart or a queen? So we have a heart or a queen would be the probability of drawing a heart plus the probability of drawing a queen minus the probability of having a heart and a queen. Does that make sense why we have to subtract? Because you have to consider what happens in the case where you have both. Now, some of you might be able to figure out the total number right from the beginning, but sometimes our numbers are really large and we don't want to have to do that, or maybe we have a table.
Lazy.
But it's
Or-
easier to see the first one, the or one instead of the and.
Well, so you could think a heart or a queen, which includes basically all the hearts or all the queens, but you don't want to count the one that's the queen of hearts. You don't want to count that one twice. So that's why we subtract it. Now, yeah, so how do you, well, how many hearts are there? 13 out of 52. How many queens are there? And how many cards that are, there's only 1, right? 1 out of 52. So the whole thing, we get, what did we say, 16?
This is the 4 of 13.
And that's 4 over 13, which is about 0.308. So just remember our rounding, we go to 3 places. Yeah, I'm fine with either. Just on the review, when we get to that, sometimes it'll be written as a fraction. Let's say it's a multiple choice, and if you see decimals, just change it to a decimal.
We have a project for final.
B. Okay, so what's the probability of drawing a black card or a face card?
So black cards, there's 26.
Right, so we have the probability of
Face card.
a black card
16.
plus the probability of drawing a face card minus the probability that we have.
So there's 12 face
And
cards.
it's funny because when I was writing this, I was like,
How did driver's licenses work and everything?
a black face card. It just, I didn't want it to sound, I was like, I should have made it with red. You get the
No,
idea.
wait.
Okay, how many black cards are there?
That's racist.
26.
I did not mean to make a racist example.
Racist. And we do the same thing.
How many black cards are there? 26? How many face cards?
12?
12? How many black face cards do we have?
4. No, 3.
Be careful.
6.
6, because we have clubs and spades. So we have 6 that are both. So we have 26 plus
32?
32. So 32 out of 52.
8 out of 30.
I didn't know.
8 over 13, which is about 0.615. Okay, you want to try the next one? Even card or a spade? Easy. So
26 over 22.
yeah, so even you've got 2, 4, 6, 8, 10. So you have 5 for each suit, so 20. How many spades? Wait,
Yeah.
13. And then how many even spades? 5. So we get 28 out of 52, which is 7 over 13, which is 0.538. So what I would like to do next, which I didn't know I wanted to do that until I'm going to look at this before I do the next example, which I don't know why I have example 2 and then example 1. I'll have to fix that. This should be example 1. Not that it matters to you guys, but for me, because I'll revise it. So I want to talk about the idea of disjoint. You need to understand, you also hear the word mutually exclusive. So these are two events that cannot occur at the same time. So sometimes, like we saw with the cards, you could have an even card that was a heart, or you could have, right, a face card that's red. Right, you can't have a black, that's an example.
Why not?
A black guy.
A black
No, it was red.
black card and a diamond. Because, so when you have disjoint, then you don't need to worry about subtracting the probability of both. So this would be the probability of a black card plus the probability of a diamond. But you don't have to subtract because it's impossible to have one of both. So with the addition rule, we really
But
only
does that
need,
not work? 'Cause you can't make there's a 0% chance of that.
or.
Percent chance of getting a black card or a diamond.
Oh, did I say and? I meant or. Well, the disjoint is these two things occurring. So what I'm saying is if you had the probability of a black card or a diamond, it would be this, but you wouldn't be able to subtract the combination of the two because it wouldn't exist. So if I just said, what's the probability of having a black card or a diamond, you would have 26 plus 13 out of 52. You wouldn't have to subtract anything.
A
Yes,
beta
sir?
fish with a tip.
Okay. A beta fish and a tick. Okay, interesting. Okay.
Pigs can't breathe underwater.
Maybe it's the dude or something.
All right.
What would the tip be interested in that?
Okay, an event, because technically beta fish and ticks aren't.
No, but you have your beta fish collections.
Okay,
You're gonna
wait.
have, what's the likelihood that you're gonna have a beta fish who also has a tip?
Wait, that's it.
Those are two separate events. A beta fish without a tip and a beta
So,
fish with a tip.
but the idea is you're reaching into a
Fish tank.
fish tank, And what's the probability that you'll pick up a betta fish
With a tick.
and a tick?
With a tick.
I'd probably have to say those would be mutually exclusive.
Voting for Hillary Clinton and Donald Trump.
Oh, that's good.
If you notice the candidates there.
Yeah.
No, they still can't count.
There is some
Because
Jill
they're out.
It's
Stein.
not voting for two presidents.
Right, you can't vote for both. And
If you do a write-in for Mike Pence,
Some people want to have other people's reproductive rights and right to marry destroyed.
okay, we're not talking politics in here. So, okay,
Come on.
complementary event. So we feel pretty okay with that last concept, mutually exclusive. Now, complementary of events. So this is when something does not occur. The probability of something occurring and it not occurring has to be equal to 1, right? Probability of it not occurring is 1 minus the probability that it will occur. Or the other way around, probability that something will occur is 1 minus the probability of it not occurring. It's kind of like if I said, and I think I talked about it, if it's a 20% chance of rain today, then what's the percent that it's not going to rain? 80. It's the complement. Okay, so FBI data show that 62.4% of murderers are cleared by arrest. We can express the probability of a murder being cleared by an arrest as probability of cleared equals 0.624. For a randomly selected murder, what's the probability that they're cleared? Not cleared, I'm sorry.
37.6.
It's just 1 minus the probability, let me write. So it's 1 minus the probability that they're cleared.
Is that the whole lesson?
Yep.
What are the differences between the slaughter and
0.376?
Yeah.
Wow, that was a good lesson.
Yeah.